Hi everybody, we're continuing the 2021 Math MCAS. This is a digital version of this in the video description as well as a printable PDF. So we're going to start with number 36. Alright, line Q is represented by this equation, y equals x. Point T as shown will be reflected over line Q to create its image. Plot the image of point T on the coordinate plane. Okay, so select the place in the coordinate plane to plot the point. So we have to reflect it over the line y equals x, which is right here. And on this problem, if you were doing this on the MCAS, I would actually, if you don't remember the formula, there's a rule for reflecting over y equals x. All right, and you basically take the x and y and you swap it. So xy becomes yx. That's what you do when you reflect it over this line. But if you don't remember that, that's no big deal. You can still figure it out. You'd want to draw the line like this with the dry erase marker. And then you simply would count the distance. So look, I'm going to go, let's see, I'm going to go 2 diagonally. This is probably the best way I would do it. And just go here. And that's where t is going to be, or t prime rather. Okay, which is going to be 6, 2, which makes sense because this is 2, 6. You would just plot the point on the screen. So you can do this without remembering this rule here. As long as you can draw the line y equals x, you can figure out where it belongs. Okay. Number 37. That's a nice little way to cheese that problem. 37. We're almost done. I think we might finish it. 37. All right, here we go. In this diagram, lines K and J are parallel. So I'm going to go ahead and draw that, show the parallel. Which statement proves that angle 1 is congruent to angle 4 and angle 3 is congruent to angle 5? So what would prove that? Well, let's see. The vertical angles formed by the intersection of two lines are congruent. Well, none of these are vertical, so that doesn't really play a part. The corresponding angles formed by the intersection of a transversal and parallel lines are congruent. Yeah, but these aren't corresponding, so that's out too. The alternate interior angles formed by the intersection of a transversal and two parallel lines are congruent. Well, parallel lines, transversal. If you extend it, it becomes a little more obvious. Then you can see, right? When you extend these lines here, you can kind of visually, I think it's easier to tell. Oh yeah, this is alternate interior. So it's going to be C. Let's see what D is. The measure of an exterior angle of a triangle is equal to the sum of the two measures of the two opposite interior angles. That's not relevant at all in this one. So yep, C is it. So really this comes down to, hey, do you know what alternate interior angles, what their relationship is when there's a parallel line crossed by a transversal? Okay. Also being able to extend the transversal helps that one. So number 38. Okay. Some students are raising money by selling t-shirts. They ordered 100 t-shirts to sell. They will sell the t-shirts for $20 each. In this equation, this equation models P, the amount of money the students will earn as a function of N, the number of t-shirts they sell. Here's the function. P of N equals 20N minus 500. So our rate of change, our starting value. What is the domain of this function where N is a whole number? What is the domain where N is a whole number? Let's see here. So if we look at this, we have 100 shirts, right? So that's the maximum they have. That's how many they could sell maximum. So we can immediately cross this out and this out because this is the maximum is 20, this is the maximum is 500. And then the minimum number of shirts they could sell would be 0. That's really it. So they could sell between 0 and 100 shirts because the domain is the number of shirts that they have on hand. The reason this is negative, I imagine, is this is probably how much it costs for them to order these shirts total. They're probably $5 a piece because that means if they didn't sell enough of them, they'd end up losing money because the functional value is how much money they earn. Does that make sense to me? So yeah, this problem, it comes down to you understand what the problem is asking you about, like, right? What the domain is. It's the input, right? P is the amount of money, N is the number of t-shirts they sell. That's probably the most important part of this problem, the number of t-shirts they sell. If we pay attention, we know they ordered 100, so they can sell between 100 and 0, and that's all we really need to do. Problem looks a lot harder than it is if you pay attention to that one. Okay, 39. Yeah, we should have time to finish this. A teacher surveyed all the students at a school about whether they participate in a sport and whether they play sports-related video games. This table shows some of the results of the survey, right here. Part A, based on the table, how many students at the school play sports-related video games but do not participate in the sport? Okay, so they play sports-related video games but do not participate in the sports. This area is blank. Well, we know there's a total of 294. So if we subtract 110, that should give us a difference, which would be the video game players that play sports-related games but do not actually play a sport. So we're going to do 294 minus 110, and that would give us 184. So it'd be 184 students. So we'll go ahead and write that in there. And that should work here. Let's see. Let's add these together. Where's my calculator? I'm a little lazy right now. 184 plus 278. This should equal 462. It does. We're good. Okay. Given that a randomly selected student from the school participates in a sport, what is the probability of that student also plays sports-related video games? Okay, so we know it's a person that participates in a sport. So it's this category here. So that's the pool we're drawing from. And then the person that plays sports-related video games, so it would be this group right here, right? So 110 out of 275, which is B. Okay. Yeah, that one, I don't know what else to say about that one. Really, we know that we're given a randomly selected student from participates in sport. So we know that the first person, the first category that with the bottom is going to be students that participate in a sport. So we know it's in this column here. So that's going to be 275, a bottom value. And then what's the probability that they also play a sports-related video game? So just put the number over it and you're good. Yeah, pretty straightforward. Number 40. Okay. In this diagram, points P, Q, and S lie on circle R. Line segment QS is a diameter of a circle. We had a midterm question just like this. So this is a diameter, okay, which means each of this is a radius. The measure of Q is 54 degrees. What is the measure of S? Okay, so there's a few ways to do this. So because this is a diameter, that means this is a right triangle, which means this is 90, and you can figure out the angle that way. That's one way to do it. There's two ways to do it. So if you know that an inscribed triangle, if one of the sides is a diameter, then the triangle itself is a right triangle, and that would allow you to figure this out because you know this is 90, that's 54. That means this plus this should equal 90 because it's 180, so this would be 36 degrees. And that'd be the answer. There's another way to do this too, though. Let's say you didn't know that. Well, you know this is 54 degrees, and you know an inscribed angle will be half the measure of the arc. So that means this would be 108. Okay? And we know this is a diameter, which means this is a semicircle. So this whole thing's 180. And this whole thing's 180. Well, that means this would have to be 72 degrees because these two arcs would have to equal an 80. And because this is 72, this would be half of that. So half of 72 would equal 36. That's another way to get S. So two ways. One, you know, if an inscribed triangle, one of the sides is a diameter, then it's a right triangle, which would allow you to find the missing side. Probably the quickest way. And the other way would allow you to do this would be through the use of inscribed angles and associated arcs. So this would be double that, 108. We know this whole thing's a semicircle. Subtract this from 180 gives you 72, and we know this would be half of that, 36. But I think if you use the method, the first one I showed, it'd probably be easier. Okay, 41. Coming down the home stretch here. This table lists some input and output values for a function f of x. Okay, here's the table. Select from the drop-down menus to correctly complete the sentence. On average, f of x blank by blank units as x increases by 1 over the interval -1 to 2. Okay, so let me just pause it and I'll write down the options here. Okay, so I wrote down the options here. So on average, f of x either increases or decreases by blank units as x increases by 1. So as x goes up, what's happening to f of x? Is it increasing or decreasing? Well, because we can do this first part pretty easily. As x increases, right, f of x is getting smaller and smaller. So it's going to be decreases for the first option. Okay. And that says on average is probably the key term here. On average. So how would I do this? Well, how many changes are there? There's 1, 2, 3. There's 3 changes, and how much do we change by? Let's find out. Let's find the difference. So let's go 8.1 minus negative 2.7, and that's going to be over 3, because that's how many changes there are. So that's going to be, let's see, 10 and 8 tenths, because it becomes plus. So 10 and 8 tenths over 3, and that is going to be, let's see, let's figure that out. 10.8 divided by 3, 3.6. So on average, it's going down by 3.6 roughly, which is the last option here. This part's a little confusing because people look at it and say, okay, this went down by 5 point something, then 3 point something, and 2 point something. So the amount is different each time, but really the key here is this. It says on average. So once you see that, you know you're probably going to find the average here, which is pretty straightforward. Also, the key here, another key is that there's 3 changes, right? It goes from here to here to here. So there's 1, 2, 3 shifts. So that's why you're dividing by 3. Because some people would divide it by 4, but there's not 4 shifts. There's 3 changes. There's 3 actual changes that occur. Okay, number 42. Last one. All right, trapezoid EFGH is shown in this coordinate plane. Which of the following is closest to the perimeter of the trapezoid? Okay, so we have trapezoid EFGH shown on the coordinate plane. Which of the following is closest to the perimeter of the trapezoid? Okay, so perimeter is length around. So, yeah, this one was interesting. Okay, so we can figure out this length pretty quickly, right? So from here to here, we're going 7, I think. 1, 2, 3, 4, 5, 6, 7. So that's 7. That's one of them. This one right here we can figure out. This should be 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. These two are the ones that are tricky. These two are rather tricky. And we have to be very careful here. So what I'm going to do, I'm going to use Pythagorean Theorem. And I'm going to use a right triangle here, and I'm going to calculate this distance. So that's what I'm going to do. A squared plus b squared equals c squared. Because that's how I'm going to find the length of that diagonal. I could use a distance formula, but I think it's quicker just to use Pythagorean Theorem, to be honest. So a is going to be 1 squared plus, and this across would be, what, 8? 1, 2, 3, 4, 5, 6, 7, 8 across equals c squared. So 1 plus 64, 1 plus 65, 65 equals c squared. Square root both sides. And we're going to round that. We're going to actually convert that to a decimal. We're going to make an estimation here because our answers are in decimals. So square root of 65 is going to be, no, that doesn't help me. Hold on a second. There we go, classic. Let's try that again. Square root of 65, there we go. So it's 8.1 rounded. Okay. And plus 8.1. And then the other one's going to be this triangle here. So to find this distance. So area is going to be 2. B squared equals c squared. So 2 squared plus, no, cross is going to be 8, I think, again. 1, 2, 3, 4, 5, 6, 7, 8, yep. Plus 8 squared equals c squared. 4 plus 4 plus 64, so it's going to be 68. Right, equals 68. And a radical 68 is going to be 8.2. So I'm going to add these together. So 17, let's just add them all together. So 7 plus 10 plus 8.1 plus 8.2, 33.3, which is the third option here. Okay, so you'd have to either use Pythagorean theorem or distance formula to calculate these two diagonal lengths. You could try to eyeball this, but I think it's very, very tricky because you have these two answers that are very close together. I mean, there are only basically 1.5 unit difference between the two of them. So actually, no, less than that. Sorry, it's actually only less than what's 0.6 of a unit. So I would not recommend trying to eyeball this. I think people would be able to figure out it's one of these two, but this is really, I think, the only way to get a close enough answer. So that's it. And obviously, you need to know what perimeter is too, which means length around, and we know it's an estimation because they say closest to. But that is that. That is all the questions on the 2021 Math MCAS. I hope that alleviates any concerns you have. And let me know if you have any questions. All right, good luck on the test.